sharing their knowledge to us. It's a wonderful thing what they have agreed. And once again, I thank for all the participants for being with us today. All the very best for the conduct of this program in a successful manner. Thank you very much, and thanks for the opportunity given to me.
Thank you, sir. Now, I would like to call upon our Director Administration, Dr. Mallasamy, sir, to facilitate the program function. Please, sir.
Okay. Good morning to all. I am very happy to join with this inauguration of the STTP program, AICT sponsored STTP program, organized by Computer Science and Engineering Department, and the topic is Trends in Machine Learning and Big Data Analytics using Python programming. It's my immense pleasure to share few words related to the recent trends. Normally, discuss are mentioned. In IT industry, the recent trends are related to IoT, Internet of Things, then the big data, the another area, then from big data, data analytics, how to get useful information from the huge volume of data. These are the some emerging areas. Therefore, this year the AICT approved a lot of new courses in these areas in the computer science and engineering field. Therefore, we have a lot of resource persons with expertise in these fields. I wish all the participants definitely will get a lot of useful inputs, information related to these emerging areas. With these few words, I wish the organizers, the program will get a great success. All the best. Have a nice day. Thank you.
Thank you, sir.
Now I like to call upon Dr. Geeta Madam for giving a brief introduction on our chief guest, Dr. Umarani Madam. Thank you, ma'am.
Good morning to all. It's my privilege to give the intro of our today's chief guest and resource person, Dr. Uma Maheshwari ma'am, Professor of CSE Department, PSA College of Engineering and Technology. She's having 19 years of teaching experience. She has published 39 journal publications of SEI and Scopus and 23 conference publications, and she has published 5 textbooks, and she had funded research projects with worth of 37 lakhs. And as a research supervisor, under her guidance, 10 scholars have completed doctoral degree and 9 scholars are pursuing. And she has played various roles as administrative support as a math, MBA, and she has organized various funded seminar workshops and all. And today we are having an eminent person for this STTP program. Now I would like to call upon our today's chief guest, resource person, Dr. Uma Maheshwari ma'am, to inaugural address. Please, ma'am.
Good morning, sir. Is it audible, ma'am?
Yes, ma'am.
Yes, ma'am. Audible, ma'am.
Okay, thank you. Respected Executive Director, respected Administrative Director, and my dear coordinators and Head of the Department, good morning to all, and my dear participants, good morning. First of all, I thank the management and the coordinators for giving me an opportunity to handle the sessions in this AICT sponsored short-term training program on recent trends in machine learning and big data analytics using Python programming. So today we will see about the various basics of the machine learning and some glimpse view of machine learning and what are the various applications of machine learning and what are the algorithms involved in machine learning. Because in a nutshell, the machine learning is considered to be an all about an automatically learning which is used for a high technical applications since it gives a high accurate result in predictions and classifiers in order to find out the unknown patterns in the data such that it can be used in many real-time applications such as the medical data, the various video analytics, that is the intelligence, the video surveillance application systems, and whatever the various real-time applications are there, we are using the machine learning in terms the artificial intelligence, the deep learning, which can be used by applying the various kinds of big data analytics. Okay, so today you'll see about also this kind of applications such as the machine learning and deep learning is considered to be one of the hot cake in the current real situations. So today we will see about that. And let me start the session. Shall I start the session, ma'am? Ma'am?
Yes, ma'am. Yes,
Shall
ma'am. Yes, ma'am.
Shall we?
Sure.
Okay, ma'am. Thank you. So let me start this session. So is it visible, ma'am? Is it visible?
Yes, ma'am. Yes, ma'am. Visible.
Okay. Shall we start?
Yes, ma'am.
Yes, ma'am.
Okay. Thank you. So first we will see about today. In the first session, we'll see about the overview of the machine learning and its applications. So generally, what is meant by machine learning? Okay. So the machine learning here in this machine learning, we are not going to explicitly program anything. Just we are going to learn. We are going to make the system to learn the various concepts. Okay, the logics, the concepts, and not we are going to program anything explicitly. Okay, what does this machine learning deals? The machine learning deals with the study which makes the computer the ability to learn without being explicitly programmed. We are making the computers to learn. Okay, so we are training the computers. So while we are making the training, we are having various kinds of learning techniques. So in later we'll be seeing about the what is meant by the supervised learning, what is meant by this unsupervised learning. So how we are making the system to learn. So such that if suppose the system is learned, for what kind of applications. Okay, so that all we'll see about the here. So why we are going for machine learning? Since the machine learning is considered to be the hard cake and it is applied for various real-time applications, whatever the applications we are considering today in the real world, for every applications in turn, we will be having some idea, at least some idea related to this machine learning. Okay. So there are many challenges in this today's world. For example, we consider we are having an interconnected world. So if suppose we want to communicate or if suppose we want to group some kind of applications, again it is dealt with the machine learning. So how to group the similar kind of data such that that grouped data can be applied to a particular applications. Okay. So again, if suppose we are having a various kinds of some kind of a complex organization, how it can be made into simple type. So in order to, if suppose we have some complex organizations, what we will do, we will make into some simple kind such that this complex can be divided into various simpler part and we will be solving the simpler part, and after solving the simpler part again we will group together in order to solve this complex organizations. And the various applications under our situations, for example, some medical kind of data or some kind of some accounts data, various inventory systems, and whatever the systems that is need to be implemented in our citizen, that can be demanded by means of this machine learning. And if suppose we want to regulate some kinds of rules and regulations in accordance to with compliance, So those kind can also be solved by means of this machine learning in association with big data. So if suppose any sophisticated threats are there, so that threats can be identified. Before identifying a particular threat, we will be training those kinds of threats into our system, and by means of identification of those kinds of threats, it can be resolved again by means of this machine learning. And if suppose any malware spreading is there, so for example, you consider while we are taking the analysis, each and every new infections are being occurred every 3 seconds. Okay. So for example, if suppose an half an hour occurs, so 45,457 instances are occurring, which is considered to be the malware threats, that is the infections. Again, it is identified, predicted, and we are preventing it by means of machine learning. So if suppose we are using many kinds of the robotic parts, that is the automated machinery parts, there also we are using the machine learning techniques in order to solve various kinds of threats. Okay. So under cyber security, if suppose we want to solve any kinds of, or we want to introduce any kinds of security threats, issues, those can also be solved by means of this machine learning. So whatever the real-time applications are there, those will be resolved by means of using the kinds of techniques such as machine learning. So while dealing with the machine learning, it is considered to be one of the application of an artificial intelligence. So from the artificial intelligence, the application occurs as machine learning, and from the machine learning, we are again arising to the technique of deep learning, where various real-time applications are solved. Okay. So now let us see about what is meant by this machine learning. So this is considered to be a learning, that is any process by which it will be improving the performance of the system. So how the system performance can be improved? Any system performance, while we are checking at the beginning, the performance will not arise to the accurate, that is the more performance will not be an excellent part. So in order to make the better performance, first we will be arising some kind of experience. First we have to solve our system, and we will be we will be finding out the performance. And after finding out the performance, if it needs some kind of improvement, so this will be improved only by means of the experience. Okay. So how this can be improved later, we will be seeing about the performance can be improved by means of some kind of neural network, artificial neural networks algorithms. For example, mainly we will be considering the backpropagation algorithms. Okay. So here the machine learning, therefore it is considered to be what? It is the study of algorithm. Its main constraint is we have to improve the performance. So how to improve the performance? It should be worked out for a particular task, and after completion of the task, we will be measuring the performance. If the performance is to be improved, now how it should be found out? It should be found only with by means of the experience. Okay, well, that is only by executing those kind of developed algorithms. So the learning task will be given with the set of the performance, the task, and the experience. So let me see about the brief history of machine learning. So in the early 1950s, initially a checker player has introduced this kind of technique of this machine learning. And in 1960s, they have introduced the technique of the perceptron. We have found out what is meant by this perceptron. That is how the perceptron is arriving from the neurons. Therefore, the neural network is considered to be, it is mimicking the behavior of the human brain. So how it occurs, how we are connecting the dendrites, the axons in between the various kinds of nodes, then how to recognize the patterns by means of the pattern recognition, and what are the various theories are there in learning, and how to separate various kinds of neurons for classification and prediction. Mainly this is dealt initially with the concept of this Minsky and Papert. Okay. Then in 1970s, in advance to that, we have introduced the various part of this induction process, and we are introducing the knowledge part into the expert systems. Then we are going for the identification part. Then we are going for the artificial intelligence in order to diagnose the various medical reasons. Then we are going for the next artificial part, and finally we are dealing with the automated machinery part. And in 1980s, we are introducing some kind of learning algorithms such as the decision tree and the rule-based learning and the expansion-based learning. And we are introducing the concept of deep learning, that is considered to be the cognitive architectures. And then we are going for the various kind of learning theories such as probably approximately correct theory. And then we are introducing an algorithm of backpropagation algorithm. Only by the introduction of this backpropagation algorithm, we are comparing with the output with the initially developed algorithms, and again we are revising it and we are getting the better optimal solutions. And after that, in 1990s, we are going to introduce the concept of the data mining, where we are introducing the concept of this association rule mining, such that we will be finding out what are the various possibilities in order to group together to have a better performance. And this reinforcement learning, the text learning, and various kinds of probability learnings by means of this base net. Then in later 2000, we are seeing about what is meant by the sub-4 vector machine and what is this personalized assistance and various robotic parts. Everything will be included under this 2000. And in 2010s and 2020s, we have introduced what is the concept of this deep learning and how this deep learning is done by accessing the data from the big data, and how we are introducing this Bayesian methods. So this all are done in order to have the multiple tasks, and this can be in turn applied to the various applications such as the speech part, the social networks part, and various vision parts. Okay. So let me see about the quick history of the machine learning. So see here, the artificial intelligence is considered to be the main part of the whole system, which is introduced in the earlier stage in 1950s, 60s, and 70s. And after the various techniques introduced into the artificial intelligence, from there we are arising about the machine learning, which releases from the 1980s to 2010. So under machine learning, it was mainly used for the classification and prediction techniques. And after finding out that, which in turn is applied to various kind of new techniques such as the deep learning. So the deep learning arises from the machine learning, where the machine learning is arise from the artificial intelligence. So the deep learning is considered to be the subset of machine learning, where this both are considered to be the subsets of this artificial intelligence. Okay. So initially we are having various the prediction outcomes. So in order to predict any outcomes, we will be using some kind of experience, and from those arised experience, we will be having some judgment in order to predict the outcomes. And after that, we are doing various kinds of manual calculations in order to predict the outcomes. So in advance to that, next step, we are going for various kinds of programming languages in order to have the statistical analysis. And after having the statistical analysis, we are going for various kinds of the statistical software in order to generate this analysis automatically by means of this programming languages. And after that, now we are coming into the step how to analyze this kind of data by means of a developed software. So in order to have those analysis automatically, we are introducing the concept of this machine learning. So what is this artificial intelligence? So this artificial intelligence is what it is considered to be a human mental function model. So where this model is done by means of the computer program. Okay. So whatever the thinkings, whatever the characters and behaviors of the human, that can be modeled by developing a computer program, which is considered to be an artificial intelligence. So from this phoneme itself, we can find out artificial intelligence is considered to be a combination of artificial and intelligence, where the artificial means what? It is not a natural. Therefore, this artificial is created by human. Okay. And intelligence means it is the ability to understand, the reason and plan. So what this artificial intelligence means? Only the human is going to understand, and after understanding a problem, he is going to give the reason and after reasoning it, he is going to plan and develop a model. Okay. So for developing any kind of an algorithm or a program, it enables the artificial enables the machine to mimic. That means what? To imitate the behavior of the human intelligence. So what are the various possible applications of AI? So the possible applications of AI are considered to be the deep learning, the simulation modeling. So if suppose we are going to use the machine translation, or if suppose we are going to use the social network analysis, or if we are going to introduce the concept of machine learning, or in order to develop the robotics, or if suppose we are going to develop any smart system by means of an internet of things, there also there occurs an artificial intelligence. And if suppose we want to recognize any images under image analytics, or if suppose we are going to give any analysis part by introducing big data, or if suppose we are going for any speech recognition part, or if suppose we are going to visualize anything, for each and every applications, we are going for this artificial intelligence. Okay. So there is an increasing popularity of this artificial intelligence. So while we are having a thinking about this artificial intelligence versus machine learning, artificial intelligence occurs for various kinds of enormous number of applications, where under this the machine learning occurs to a particular kind of applications, for example, the predictions and classifications. So while considering this artificial intelligence and machine learning, artificial intelligence mainly deals with the search part, the planning part, and after that it goes for an expert system by means of a knowledge representation. And it also deals, after this, it also deals with the natural language processing and what is the perception occurs from the above knowledge representation and how we are using this under robotics. It also uses the concept of this machine learning, that is the data science, where under data science, we will be analyzing the various kinds of data, that is the enormous amount of data. So in order to have the group and in order to have some classification or clustering for that, data will be going into the data mining part. And in order to access those data, will be going for the database. So what is this machine learning? Again, it deals with what? It gives the computers the ability to learn without explicitly programming. Therefore, its main use is what? It is making the predictions from various kinds of data. Okay. Next class. So see here the steps are, initially we'll be having the training set. So under training set, we'll be having two techniques. Either it may be a supervised learning or it may be an unsupervised learning. So from there, we will be extracting the various kinds of features to the feature extraction part. And again, it is given into the machine learning algorithms. So under machine learning algorithm, there are various enormous number of algorithms are there. And by means of that algorithms, we will be using and we will be grouping of the similar objects. Either it can be used for grouping of objects, that is the clustering, or it can also be used for the various kinds of predictions by means of introducing any kind of prediction model. And after that, we are annotating the particular data. So why this machine learning is considered to be hard? See, this is considered to be an image. If suppose we, the human, if we are seeing it, we will be just seeing the background or the overview of the image. That is, the two boys are there, two kids are there, and they are laughing and seeing. If suppose it is inserted into the machine learning algorithm, see, it represents various kinds of data and it sees into the overview of the inside the picture. What does it represent? What does its background represent? So what kind of kid is this? Whether it is a male kid or it is a female kid, what are the various actions related to that kid? Everything will be represented by means of this machine learning, and hence it is considered to be hard. So see here, there are various characters are there. So if suppose we are seeing it and if there arise a question, what is a 2? Thus we are seeing about the similar pictures and we will be grouping. But see here, the machine learning, what does it do? It sees and it compares the particular character with each and every characters in the image, and it finds out individually, and it takes a large amount of time, and it does a large amount of work in order to have the prediction of a given asked particular character. See here, if suppose a particular image is there, see here 3 images are there. So we are representing a machine learning to identify an apple. So if it is an apple, it represents 3 features. One is the color and another one is the type and shape. So the first one is considered to be an apple, and the second image is considered to be an apple corporation. That is, it is considered to be a symbol of the corporation developed by Apple. And the next one is considered to be the peach. So in order to predict and classify these kind of images individually, they are representing 3 kinds of features. One is the color, another one is the type, and another one is the shape. So if suppose simply it represents, simply it gives the image, and if we want to recognize, you just see the image and we'll say it is an apple. But the system is to be modeled to identify whether it is an original apple or whether it is a symbol or whether it is considered to be any kind of fruit. Okay. So hence the machine learning is considered to be hard. In order to identify this, we have to develop various kinds of features and we have to develop the model. Okay. So see here, this is considered to be an image which represents a cat. So if suppose we are introducing this into the system of machine learning, so what does it represent? The image is given as an input. So the various important features to be extracted from this image and it is given as input. And after that, it is trained to various layers of the network and finally it produces the output. So what are the various important features in order to represent for this image cat? Now we have to find out what are the various important features are there which is different from other animals. Okay, so here they are representing it to be the fur, the whiskers and the claws. So the traditional programming is considered to be what we will be developing a program, and after developing a program you will be inserting the data, and the computer processes the program and reproduces the output. So if suppose we are using the machine learning, what we will do, we will be inserting the data and also the output. So the computer trains with this data in order to get the given output and then it reproduces the program. Okay. Thus, this is the difference between the traditional programming and machine learning. Where in the traditional programming, normally a program will be developed and the input data will be given and produces the output. But in order to have the best prediction system, we are introducing the machine learning where the data and the target output should be given as input to the computer such that it should compare both the data and the output and then it reproduces the program. See, this is considered to be one of the learning. So the various images are there. So from this we have to find out which group does this particular each and individual object belongs to. In order to have this, we will be going for the clustering and grouping part, which will be again introduced by the concept of machine learning. So all this training data, that is all the this training data will be given as input to the learning algorithm. So this learning algorithm, it learns and trains each and every data and it will be given as output to the trained machine. And if suppose any query is given to this trained machine, the exact answer will be developed from this machine learned trained machine. So some examples of this machine learning classification are: machine learning can be used in classification images and objects in an image, such as in order to identify in a shape whether it is in water or it is sand or whether it is a rock or what kind of an object is there. So for every kinds of classifications, we will be going for this machine learning. So then where all machine learning is used, if suppose we are in need of some kind of technique, such as if we are in need of navigating on Mars, the human expertise cannot be used in order to navigate the Mars. So what we are doing, we are introducing the concept of machine learning into the various kinds of jets and rockets, and then it is inserted. So the main machine learning technique is introduced into the Institute of the CISRO, and they are using the concept of this machine learning and deep learning for various kinds of applications. So whatever the navigations are done by means of a satellite, this machine learning techniques are used. Okay. So if suppose we are in need of any kinds of recognition techniques such as the speech recognition, that is the conversion of speech into text, irrespective of the speakers, this will be implemented by introducing the machine learning where the humans can't explain this expertise. Okay. So if suppose any medications are there under medical image processing, or if suppose we are going to develop any smart medical system, so the personalized medicine properties will be introduced by means of this machine learning by customizing the models. Okay. So under genomics part, if suppose we are going to introduce under medical process various kinds of genomics, there also we are using the huge amounts of data. So this can be developed by introducing a model of machine learning. So some more examples are for recognizing each and every patterns. For example, the facial identities or the facial expressions, the handwritten or the spoken words, and the medical images. We are recognizing the patterns by means of this machine learning. And if suppose we want to identify any threats such as the unusual credit card transactions, or if suppose under nuclear power plant or under DRDO defense organizations, if we are sensing any unusual patterns, those can also be anomalies can also be detected by means of this machine learning. And it is also used to predict under stock market what are the various shares. So these all are considered to be some kinds of machine learning applications. So see here the input, they are given a motorcycle as the input, and if it is inserted into the model of the machine learning, it should develop an output such that it should give a label as motorcycle. So in order to identify that, what are the main features they are considering? See this axle part here, this is considered to be the main part in order to, they are identifying these to be the motorcycle. So the various features are extracted and the various pixel values are extracted from this through cameras, and they are considering it. And if suppose for example there are 4 kinds of images are given, and if suppose from this raw data, if we are in need to identify the motorcycle, first what they are doing, first they are introducing a learning algorithm for predicting and grouping of images. So here, if suppose they will be having some kind of feature, suppose if wheels are present, then it may be vehicles. If lights or headlights are present, so this may be thus some kind of features in order to have a part such as vehicle. So this may be they are grouping together as one is considered to be the cars and the others are considered to be the non-cars. And after that, we have to cluster this. So if many images are there, they are first they are classifying it into cars or non-cars by means of a learning algorithm. And after that, they are grouping the cars separately and non-cars separately. So how they have separated this? See here by means of the wheels and handles. Okay. So with this, they are separating whether it is a car or non-car. See, the wheel and the handles are considered to be the 2 features under this learning algorithm in order to separate out this all input images. And after that, they will be grouping this. And if suppose we are going to find for a particular vehicle, then the separate this, see here, this extracted features will be considered for that particular vehicle, and then they will separate from this grouped figures. Okay. So from the machine learning, we are coming ahead to the deep learning. So under this deep learning, see the various pixels are there, and from there we will be finding out the edges of each and every image part, and then we will be combining this kinds of all kinds of edges, and finally we are developing the object models. So this is considered to be a learning representation part. Okay. So the sum, while we are considering the whole image, the sum part will be considered as some part, patterns will be considered as smaller than the whole image. So if suppose we want to identify this kind of bird, so this can, they are identifying this particular bird by means of this beak, and we are going to identify what is this. Okay. So from the whole image part, we are extracting a particular feature, and this particular feature is summed up and it is inserted into the deep learning, that is an artificial neural network. From there, it is given to the activation function, and finally it will be developing the output, and it will detect that it is a beak detector. Okay, we are detecting what? The beak of the particular bird. So it represents what? A smaller region. Since we are representing only a smaller region, the parameters will be also few. Okay. So if some pattern, see this pattern is appearing in a particular place and this pattern appears in some other different place. So if suppose we are training a lot of such kind of this small detectors, and each detector will be identified whether it is an upper lip detector or whether it is a leaf detector or whether it is a middle beak detector. Okay, so how it can be extracted? Again, this upper beak detector will be calculated by means of this extracted features and it is summed together. And if suppose we are using the middle beak, now this features will be extracted and it is summed together. And then it is inserted into the activation function and it will be developing whether it is, and it will be classified and it will be predicted whether it is an upper left beak detector or whether it is a middle beak detector. Okay. So it is also used to have a visual feature learning. So this visual features can be made clear and it can be recognized by means of introducing a convolutional neural network. So what does this convolutional neural network does? It has various kinds of layers, convolution layers. So under each and every layer, a particular feature is extracted, that is an image, a particular image is extracted from the whole image and it is given to each and every repeater, this convolution layers, and finally it produces a clean image. Okay. See here it is considered to be a corrupted image. So from this corrupted image, we are developing a kernel, that is we are developing a feature map. Again, that is mapped into the next layer, that is the full layer. And finally, we are after subdividing each and every image from this whole image, we are cleaning up the image and finally we are embedding all this small images and then it is cleaned by means of again introducing into the convolution layers and finally we will be arising out of a clean image. Okay, so this is done. The whole sub images are represented into the stack and then it is each and every image under the stack is inserted and it is implemented under various convolution layers and finally it produces the clean image. So this is done by means of this feature engineering. So what does this feature engineering represents? In order to have or in order to recognize the clean image, we are using various kinds of expert systems. That is, we are using the domain knowledge of the data such that it will be used to create various features, which in turn it is used under the machine learning algorithms. Okay. So when we are working under the machine learning problem, the feature engineering will be done manually. And after this, we will be introducing the expert knowledge into this in order to have the best accurate results. Okay. So the sample applications are, it is used under the web search, it is used for the computational biology, and under finance part for stock market, and under e-commerce, and for robotics, the information extraction part, and under social media. So under social media, if suppose the machine learning occurs, it recognizes the characters of each and every person. And if suppose a particular person open his social media, it will be displaying all the images relevant to that particular person, whatever he is searching every day. Okay. So in order to define the learning task, as we have seen previously, what does it do? It improves the task by means of by looking out the performance based on the experience. Okay. So if suppose we are dealing with the playing checker problem, the task is what? He is playing the checkers. And what does his performance indicates? The percentage of games he wins against the arbitrary component is considered to be the performance. And how it can be improved by seeing out his experience, that is how he is playing these games again by himself. Okay. So if suppose we want to recognize the handwritten words, what would be its performance? Its performance will be calculated by how many amount of words we are recognizing correctly. So the experience is what the database of this human labeled handwritten images will be considered to be the experience. Okay. So if suppose we want to recognize the handwritten words with 100% accurate, then what we should do? The handwritten images, handwritten words to be made clear, which is considered to be the experience. Okay. If suppose we want to drive on the 4-lane highways by having some kinds of vision sensors, so the performance of it will be calculated. So how the human is driving to how much distance for a particular time, that will be done, that will be calculated for me by means of a performance. So how it can be done, what will be the experience? So what kind of steering commands he is recorded while observing the human driver, that will be considered to be the experience. By having this kind of experience, we can improve the task of the driver such that the performance can be increased. Okay. So if suppose we want to categorize the email message, either it is a spam message or legitimate message, then we have to classify both kinds of messages, whether it is a spam or non-spam, and this can be inserted into the database and we can predict the result of this categorization of message. So there are few large amounts of tens of thousands of machine learning algorithms are there, and it is being introduced each and every year. Okay. So whatever the algorithms are developed under machine learning, mainly it has three components. One is considered to be how we are going to represent the algorithm by inserting the data, and how we are finalizing the algorithm by means of this optimization, and how we are evaluating the algorithm. Okay. So these all are considered to be the various functions represented under developing this algorithm. One is considered to be the numerical function. So why we are using the numerical functions? We will be introducing the concepts of the linear regression. So regression means what? It is considered to be a continuous task. It will be giving results in from zeros, in between zeros and ones, with a continuous task such as fuzzy logic representations. Then various other numerical functions are, it will be introduced by means of neural networks, then by means of this support vector machines. Okay. Then some kind of symbolic functions are also there. So the symbolic functions can be represented by means of introducing the concept of the decision trees, then the rules and propositional logic, and what is meant by this first order predicate logics. Okay, so what are the various hypotheses occurs from the various kinds of inductions that will be introduced by means of the symbolic functions. So if suppose we want to group, or we want to cluster, or we want to find the distance, or for any kind of predictions, we can also use this kind of functions such as instance based functions, where we'll be using this nearest neighbor and case based techniques. So if we are having various kinds of probabilistic results, either it may be true or it may be false. So those kind of results can occur by means of this probabilistic graphic models by using Naive-Bayes theorem, the Bayesian networks, the hidden Markov model, and various context-free grammars and the Markov networks. Okay. So in order to have the search algorithm or an optimization algorithm, mainly we'll go into the technique of this gradient descent, where we are using the perceptron and backpropagation techniques. Then we will be using the Markov models under dynamic programming. Then the rule-based learning under decision tree induction under divide and conquer. Then we will be going for some kind of this mutation part by using the genetic algorithms in the evolutionary computation parts. Okay. So after finding out this, finally we'll going into the evaluation part. So why we are going for the evaluation part? In order to get the better accurate result. So this will be calculated under this evaluation. So it evaluates what the accuracy of the system, the precision and recall of the system, what is the squared error. After finding out this error, we'll be going for the improvement of the result, and what is its likelihood approach, and what will be the cost of the developed system, and what will be the entropy level of the system. Everything will be learned, and what is the scale learning divergence, everything will be studied. So in order to have the practice of this machine learning, the initial step is what? First, we have to understand the domain, the prior knowledge and the goals of a particular developed system. And after finding out the domain and the goal, that is the main objective of, in order to develop a system, we'll be going for what are the various kinds of data are in need for that particular model. So after finding out the data, we are going for this data integration. So we'll be going for the selection process. If suppose any error or noise is there, we are going for the cleaning process by means of this pre-processing techniques, etc. And after this completion of this initial step, we will be developing the model, that is the learning of the models, and what kind of algorithm can be used for that particular applications. And after finding out the models, we'll be going for the results part, that is the interpreting the results. And after giving performance by means of this results, we'll be consolidating and deploying these discovered knowledge. Okay. So what are the lessons can be learned about this learning? Either it can be a direct experience or it may also be an indirect experience in order to have the target functions. Okay. So there are different learning methods are there with a different hypothesis and different searching techniques. Okay. So if we are combining this Facebook and where we are using this artificial intelligence techniques, see, we Facebook with the machine learning, what we will do first, we will be analyzing the textual part of each and every individual person who is logging into the Facebook. Then it will recognize the facial recognition, and then we will be targeting the various advertisings what that particular person is using. And after finding out this all recognition part, we will be going into the design part of that particular person AI application. And after that, what are the various news feeds are there for a particular person, and who all are the friends recommendations for him, and if suppose any detections are there related to the crime, that can be detected, and the videos and images also are also detected. Okay. So if any person enters in the Facebook, the machine learning, if you are introducing the machine learning, what does it do? It recognizes the various each and every individual key characters of that particular person. So whenever he is again logging on into the Facebook, into his logging, or what are the various texture part or what are the various news feeds he is seeing out, that can be automatically displayed whenever he is logging on into the system. Again, the Google machine learning. So the Google machine learning also, the mail part is there, the Google Drive is there, Google Chrome is there, and various kinds of music players or various applications are there under Google. Again, if suppose we are introducing the machine learning, and whenever he is going there into the Google, by introducing machine learning techniques, it is used to translate the messages, and it is used for the voice searches also. And if suppose we want to search any photos into Google Drive, again it can be searched by introducing the image, and it will be compared with the stored images in the database, and it will be displaying the particular image. And if suppose we want to have any smart reply, that can also be developed by means of this machine learning model. And the various Google Maps, in order to travel and in order to reach a particular target place, that this also arises by means of this machine learning algorithm. Okay. So again, it is what it is considered to be science of getting computers to act by itself. Okay. So since it is considered to be a subset of an artificial intelligence, it uses what various statistical analysis and various statistical algorithms in order to improve their performance. So the first step is what? Machine learning. It is a subset of an artificial intelligence, or we can also tell as it is an application of artificial intelligence. So first it uses the statistical methods, and also it enables the system to act and take the data by having a decisions to carry out a particular task. Then they are developing and designing an algorithm in such a way in order to improve the performance. So how the performance can be measured? The performance can be measured with the accuracy, and it will be measured with the data, whether we are opting for a correct data. Okay. So for example, you see, suppose we want to create a system. If suppose we are measuring a height of a particular person, then what it should be is weight. Okay. So in order to develop this simple system, first we should collect the data, and after collecting the data of the height and weight of each and every person, we are plotting the plot under a graph, and after that we are starting by drawing a simple line with some predicted weight and height. So the simple line will be what. So if suppose we are knowing the height of a particular person, so how the weight can be measured? The weight can be measured by subtracting the numerical value 100 from the height. So they are doing that. See here, a simple line could be drawn. So where the weight can be calculated as the measured height value minus 100. And after this, we are drawing a plot and we are predicting the results whether it is giving a correct result or not. So if it doesn't give the correct result, we have to find out the errors and we have to estimate the value and the actual value by finding out the errors. So in order to achieve this, by calculating this, by introducing this line, we are calculating the difference, and that is the distance between 2 points, and then we are finalizing the result. So if the error is considered to be more, again we are doing what? We are improving the results by means of adjusting the weight values and the height values. Okay. So our main goal in this system is what? We have to minimize the error such that the error should be what? Error should be small. So the error between the actual and the estimated value should be decreased such that the performance of the developed model should be increased. So whenever we are, so in order to have this, we are feeding a new kind of a new data, that is the height of the person. So if the height of the person is given, it should exactly give the weight of the person by means of having the difference in between the height and the 100. Okay. So this all are considered to be various kinds of machine learning problems and their descriptions and examples. So the various kinds of machine learning problems are considered to be classification is considered to be one of the kind of problem, regression, clustering, association rule mining, which deals under the data mining part, then the structured output, then we are going for the prediction, that is the e-commerce under ranking. Okay. So classification means we are classifying a particular data from a group of data. For example, if suppose we are having a group of animals in an image hold together, we are classifying whether it is a cat or it is a dog or the name of that particular animal. Then if suppose we are using a regression part, it will predict only the numerical values. Under classification, it will be picking up any one of the labels. Under regression, we are predicting the numerical values. Okay. If suppose we are using the clustering part, it will group all the similar images. That is, what are the similar examples are that will be grouped together. If suppose we are using ML problem, that is an association rule mining, it will likely infer what are the various association patterns are there. Okay. So this is, and the next one is considered to be the structured output. If suppose we are in need to create a complex output, then there we will be using this structured output machine learning problem. And if we are in need to identify a particular position on a scale, then our within research ranking, so there we will be using the machine learning problem such as ranking problem. So the machine learning, it does what? We think about a particular problem, and by thinking about the problem, if there is a need to change the problem in order to have a better performance, that can also be done. So how it is doing that? It is introducing a mathematical science and converting it into the natural science through various running of various experiments using the various statistical analysis and finding out the results. Okay. So see, if we are going for the classification part, so under classifier, for example, we are going to consider an example as email messages. So it will be different classifying into the original useful messages and the spam messages. So the useful messages will be classified and it will be given into the inbox, and the various unnecessary messages will be sent to the spam folder. Okay. So this is done by means of a model, that is the classification model. So in order to have the classification model, we are introducing the concept of machine learning, and it predicts the values with the one or more outcomes. So if suppose we are using the regression problem, if suppose we have to give the data whether it is a real data or it is a continuous data, those will be displayed by means of using this technique, that is the regression. So here we will be having two kinds of regressions. Mainly it is a linear regression and logistic regression. So under linear regression, it will be used in order to have yes or no technique, yes or no results. So the simplest technique is considered to be the linear regression. And if suppose we are going to fit the data in the continuous manner, we will be using the logistic regressions with by means of the best hyperplane, which goes through the points. So if we have the techniques and if we want to see around this classification and regression, so the basic parameters under this are, under classification, the mapping functions will be used in order to predefine the classes. Under this regression, it will be the mapping function. It is used for what? The mapping values to the continuous outputs. Therefore, under this classification, it is mainly used to predict yes or no. Okay, whether the result is yes or it is not found. But under regression, the prediction of continuous values will be done. Okay. So under classification, the predicted data will be an unordered data. But under this regression, since it is considered to be a continuous prediction, it will be having an ordered predicted data. Okay. So under classification, since it develops the discrete values, we will be measuring the accuracy. But under regression, since it's considered to be a continuous value, it measures the root mean squared errors. So the various algorithms used under classifications are the decision tree algorithm, the logistic regressions. But under this regression tree, we will be using the random forest and the linear regression techniques. Okay. So see the regression and classifications. So in order to have the regressions, if suppose we want to predict the age of a particular person, or if suppose we want to predict the house price based on a particular area, or if suppose we want to predict the number of copies of a music album, so this all predictions will be done by introducing the technique of regression, since it has a continuous representations. Okay. So if suppose we want to predict an accuracy, whether it is an yes or no or a single particular result, we will be going for this classification process, that is predicting the nationality of a person is considered to be the classification. Or if suppose we want to predict whether the stock price of the company will increase tomorrow, yes or no, it will be represented by means of this classification. Or if suppose we want to predict the gender of a person by means of his handwriting, that can be developed by means of a classification. That is, the results will be either this or that. That is, either the gender will be male or female, or by increasing partner, yes or no, or nationality, the nationality of a particular person. And if suppose the weather monsoon will be normal next year, yes or no, it also deals with the classification process. Okay. That is, it is not developing any continuous output. This will give some kind of discrete value. So whatever the system they are developing for a discrete value, that is considered to be the classification part. And the next one is considered to be the clustering, where we are grouping together the similar data. Okay. So mainly the clustering will be coming under the unsupervised learning, because the clustering means what? It is the task of dividing the data into the number of groups with the similar data. Okay. So basically it is considered to be a collection of objects. So how it will be collected and grouped now? By means of their similarity and dissimilarities. So here it is considered to be the pre-clustering, where we are having a large enormous amount of objects or data. So by depending upon their similarities and dissimilarities, under post-clustering we are grouping it together. And the next one is considered to be the clustering applications. So the various clustering applications are, it can be applied to marketing or biology, the libraries, the insurance part, the city planning and the earthquake studies. Okay. So under marketing part, it will be used If suppose a particular customer segments are there for marketing purpose, then we will be grouping together depending upon his behavior, what are the part or what are the jobs he are in need to develop to each and every particular company. Okay. So if suppose we want to classify any species of plants and animals, again it can be grouped together the characters of plants or the characters of animals in the biology part. Okay. And if suppose we want to arrange or group together the similar kinds of the topics and informations of a particular books, that will be done by means of this clustering techniques in the library. Okay. And if we want to have the customers and if we want to acknowledge them by means of developing their policies and frauds, that can be grouped together in the insurance by means of this clustering. So the various kinds of applications are there under this clustering. Okay. So in order to work with the machine learning, what are the various steps involved? Now the first step is we are setting the research goal. Okay. That is the objective of a development of the particular machine learning model. And after that, we have to have a hypothesis. That is the reason in order to develop the particular objective. So after finding out these two parts, we will be collecting the data relevant to our objective and hypothesis. And after collecting the data, with those collected data, we will be testing our reason, testing the hypothesis. And after testing the part, we will be analyzing the results and we will reach out the conclusion. And if suppose the conclusion is not satisfied, then again we have to refine our hypothesis and we have to repeat the steps from the process 3 to 6. Okay. So this is considered to be, see here, the objective or they have given want to predict how the heavy traffic will be given on a particular day. So in order to have the reason, maybe the weather forecast in the informative signal is weather forecast is also considered to be a particular constraint. So in order to have this, we are collecting various historical traffic data and weather on each and every day. So in order to test it on a particular day, we are collecting the traffic data and weather on that particular day, and then we are training a model using those data. And then after training the model, we are testing out whether we are producing a better result than the existing results. So if it is better now, we are producing the conclusion, and if it is better, we are stopping out the process. Otherwise, we will be refining the hypothesis and we will repeat the process from 3 to 6. So in order, if suppose the machine learning problem is considered to be hard, sometimes the machine learning it is used for the people in order to find out the anomalies. So how to decide an anomaly to get the labeled data? Okay, so that will also be done by means of this hard machine learning problem. Okay. So the classification problem is also considered to be a hard machine learning problem, where it is found to be hard. That is, in order to identify the correlations, that is the mutual relationships or the connections in between two or more things. It is easy to see that something has happened, but it is hard. It is always hard to find out why that particular incident has happened. Okay. So in order to find out that, we are introducing the machine learning and what are the various happenings that can be done and how it can be identified. So the brief overview on the learning. So in order to have the machine learning, the elements will be the performance element used, excuse. Ma'am, Geeta ma'am. Geeta ma'am.
சொல்லுங்க மேம்.
1 minute ma'am, 1 minute. Hello.
சொல்லுங்க
Ma'am, 1 minute ma'am. Sorry for the disturbance ma'am, 1 minute. Okay.
ஓகே மேம். ஓகே மேம்.
No.
pressure on them and also.
Geeta ma'am,
Ma'am.
I'm whether able to see my screen.
Hello, ma'am.
Able to see?
Yes, ma'am.
Okay, okay. Shall we continue?
Yes, ma'am.
Okay, ma'am. Okay, participants, sorry for the disturbance. So we'll continue. So first we will see about the learning elements under this machine learning. So while we are designing the machine learning models, the various learning elements are, the first one is considered to be the performance element. The next one is considered to be the what are the various functional components to be learned. And the next one, how we are representing those functional components and what are the various available feedback are there. So the performance element used are, the first one is considered to be the utility based agent and what are the various reactive agents are there and the logical agents. So this all are considered to be the various agents in order to measure the performance. Then the next one is considered to be the functional component to be learned. The functional components are the classifiers, the evaluation functions, and the perception action functions are considered to be the functional components. Then how we are going to represent these functional components? We are going to represent by means of using various linear functions. So the linear functions and the various logical theories and what are the various models. So here we are using the hidden Markov model. And after that, what are the measuring that, what are the various corrective actions to be performed, which will be done by means of this feedback. Okay. So this all are considered to be the learning elements. And the next one is considered to be the dimensions of this learning system. And in order to have the dimensions, we will be using what are the feedback we are going to use, whether it is a supervised learning or unsupervised learning, or it is a reward function, that is a reinforcement learning. And how we are going to represent the vectors, whether it is an attributed based vectors or we are going to use the relational logics. Okay. So after that, what kind of knowledge can be used, whether it is an empirical knowledge or it is an analytical knowledge. And the way outline of the system is what? It is considered to be a supervised learning, unsupervised reinforcement, then finally we'll going for the performance evaluation and the computational learning systems. So if suppose we are using a supervised learning, what is meant by the supervised? It is inducing a representation of the function. For example, you see the target function is f such that x tends to y. So the example, if we are using x comma the function of x naught, the reason the hypothesis will be such that when we can tell the g of x is equal to f of x. So if x tends to y is equal for both the functions f and g, then we can tell it as g of x is equal to f of x. That is, already a function is defined, and the same function will be used for the hypothesis also. That is considered to be a supervised learning. So where here the x is considered to be what it is? A set of attribute values, and also it represents the set of logical sentences. In turn, the y is what? From that attribute value representation, we can do the classification by means of y, that is the set of discrete labels. Okay. And after this, we are going for the regression part, y is equal to r. So in order to have these kind of part, we are going for the decision tree. So for example, you see the decision tree we are using in order to decide whether we have to do a particular task or not. If suppose in order to have the task, what are the various possibilities? If suppose we are not in a situation to do the task, what are the various possibilities are there in order to decide that? Okay. For example, you see here it is given an example. So here the patterns represents what? How many people are there in a particular restaurant. So decision tree, what we are going to decide, the example is, should I wait at this restaurant? Whether we have to wait at this restaurant. So this is considered to be the question under decision tree. So here the pattern represents how many people are there in a particular restaurant. Either it may be none, that is no one is there, or it may be some people are there, or it may be it is fully occupied in that particular restaurant. Okay. So here we are if it is none, then we can decide we can use this restaurant. If some people are there, here also we can decide, okay, we can use this restaurant. If suppose it is fully occupied, then the next step is what? We have to calculate the weight estimate. Okay. So the weight estimate here, it subdivides into these parts. One is if suppose there are less than 10 people, or if there are 10 to 30 people, if there are 30 to 60 people, or if it is greater than 60. So if it is greater than 60, now we can conclude we should not wait at this restaurants. We can go for any other option. If there is 30 to 60 people, then they are going for an alternate option. So under this alternate, they are going whether we have to reserve or whether we can opt Friday or Saturday. That is whether the particular condition is true for Friday or Saturday, or we can go for an alternate restaurant which is nearby. Okay. So after that, if it is we are deciding we are going for any other restaurant nearby, then again we are going for an option. If it is yes, na, whether any other option, whether any other restaurants is nearby na, we can opt this. Or if any other restaurants not nearby na, then we go for the next option, whether any bar is present in order to wait there. Whether any bar area is there in order to wait for the customers. If no na, then we have to neglect this. If yes na, we can wait there. Okay. So if it is true for Friday or Saturday, if it is yes na, we can wait. Or if it is not true na, then we can quit that particular place. And if it is 10 to 30 people, and if he is considered to be hungry na, we are going for an alternate option. If he is not hungry na, he can wait. So under alternate options, whether if suppose any alternate restaurant is nearby, if it is not na, then we can neglect. If there is nearby na, again we have to go for the condition whether the background, whether the environment there is raining or not. If it is raining, na, again we have to wait. If it is not raining, na, we can quit this particular place and there is no need to wait at this restaurant. Okay. So this is a simple example in order to have the decision tree. So what are the applications we are using, and under machine learning, we can use this kind of decision tree technique. So what is the induction from this decision tree? So here we can do various kinds of partitions to the most important particular attribute. Okay. So what are the main key concepts under this decision tree? One is considered to be the entropy. So here we will be having a impurity of set of examples are there, and we are encoding the particular class in order to have a better example. Okay. And in order to have the better implementations, here we are in need to reduce the entropy which is caused by the various kinds of partitioning techniques. For example, you see a good attribute splits the examples into subsets. Either it may be all positive or it may be all negative. See, these are so many peoples under the patterns. If none is present, if some are present, and here full are present. If suppose we are going to use the type, which type of people are there, whether he is French or he is an Italian or Thailand or burger, everything will be grouped together. Okay. So from this, they are drawing an analytical versus graphical result. They are grouping, they are identifying and predicting. And see here too many people from this group are there, and this many people are present. This 3 people are from this group are present here, and again we are subsampling it. Okay, see, again this is separated. These people are separated. This is separated, and this is separated. Okay, so this is hence we are using the decision boundary and decision tree induction, and hence they are telling it as what? Expected reduction in entropy caused by what? Partitioning. Just by doing partitioning, they are reducing the entropy level in order to reduce the errors and have the better result. Okay. And the next one is considered to be an artificial neural network. So under this neural network, what it does, it mimics the behavior of the human. So it is that is the normal human brain consists of 10 power 11 neurons, where it consists of similarly more or less 20 types of neurons, and each neuron is considered to be a small computational unit. And this under neural network, the units are connected by direct weighted links, and activation functions are used. See here, this is each and every neuron in our brain. This is considered to be a nucleus. In order to travel the information from one neuron to another neuron, we are using this channel, that is an axon. And this axon from various neuron cells will be connected to this cell, and each and every one is considered to be the cell body. So this in turn is developed similarly by means of a neural network. This is considered to be an activation function, and this is an input function and an output function, and the axons are considered to be the bias weight value, and this is considered to be a cell body, which in detail we will study in the next session. Okay. See here, this is considered to be the neural network. So each and every one is considered to be the neuron. See, this is the first feature 1, and the second feature. This in turn is developed to the next layer neurons 3 and 4, and finally it produces the output 5. Okay. So how it is given an input from one neuron to another neuron? See, for each and every connections we are assigning a weight value, and by constant we will also be having a bias value. So this is considered to be the first neuron, and this is considered to be the third neuron. So it is connected by means of the weight value W of 1, 3. So the first neuron is connected to the fourth neuron. It is connected by means of W of 1, 4. Similarly, from the second neuron to the third neuron, we will be having the weight value W of 2, 3, then W of 2, 4. And this is given as input. It is processed under this by means of the activation function, and then that output is linked with this weight value and given an input to this fifth node. Similarly, here it is given. See, Therefore, the output of A5 is what? The function of the weight value of W of 3, 5 into A3 plus W of 4, 5 into A4, which in turn A3 is given as what? W of A1 into W of 1, 3, then A2 into W of 2, 3. Similarly for this, A1 into W of 1, 4 and A2 into W of 2, 4. So this all values to be calculated and we are obtaining it, the output, by means of developing an activation function. Okay. Therefore, the neural network means what? It is considered to be a parameterized family of various nonlinear functions. So the types of networks are either it may be a cyclic network or it may be a acyclic network. Under cyclic network, we are using the recurrent network, where the networks used are the half-field network and the Boltzmann machines. Under acyclic, we are using the feed-forward network, where we'll be using the single-layer perceptron and the multi-layer networks. Okay. So under neural network learning, it adjusts the weight, it changes the functions represented by the neural network. So iteratively, it will be adjusting the weight by minimizing the errors in order to have the better output. Okay. So how to update the weight values? The weight values can be updated by means of various kinds of rules. Some of them are the perceptron training rule. We can also use the delta rule or linear programming. And finally, after changing the weight, it will be the results will be developed by means of this backpropagation algorithm. See, by means of decision boundaries, we are doing the partitions. So if suppose we are using a single layer perceptron, we will be using a single plane which will separate the similar groups together. If suppose we are using a multi-layer network, we will be using a multi-layer partition. So support vector mission is also considered to be one of the method under this machine learning. So what does it do? It will be mapping the data to the higher dimensional space, which can be separated by means of linearly separable. Okay. So here, in order to learn a classifier, we'll be using an optimal linear separator, which has what? A large margin, in order to have the positive examples on one side and the negative examples on the other side. And they will be also using an optimization technique of the quadratic programming. Okay. So under the support vector machine, where the main key concept is it will be training the data in order to have the better optimization problem. Okay. So the weights associated with the data points will be 0, except for those points which are nearest to that particular data. So in order to have efficient training under this, we are using a function that is the kernel function, which the kernel function is applied to each and every pair of points. So here it will be developing the particular value feature space, high dimensional space, by having the dot products of the vectors. See here, support vector mission. Here we are using the decision boundary. So here we are using various number of partition planes in order to separate this similar groups. And the next one is considered to be the Bayesian network. The Bayesian network mainly it uses the concept of the probability distribution. So in order to have the probability distribution, it will use either yes or no, that is the condition of true or false. Okay, the positive value or the negation of the positive value, that is the negative value. So see here, an alarm is given. Either if the burglar is there, a theft is there, then an alarm will be sent. If an earthquake is also there, an alarm will be sent if it is considered to be a smart system. Okay. So if an alarm is introduced, it will be introduced by means of a neighbor call. If an earthquake is there, it can also be given as alarm to the neighbor call, or it can be directly given to the neighbor call, or it may be displayed by means of a radio report. Okay. So the two data are there. If both are positive, then their contribution will be the maximum 0.9. Then the negative value will be 0.1. If one of them is considered to be the negative num, and the negative value will be considered to be maximum. If the main concept is negative now, it is considered to be maximum. If equal contributions are given for both reasons now, then equal contributions will be given to their outputs. if both are found to be negative, now the negative of the maximum possibility will be given as most probable positive value. So for this Bayesian network, we have to find what is the most probable reason for giving the data. Okay. So in order to use the posterior probability, it is weighting the hypothesis process. What is the main reason? So we are using a single maximum posterior hypothesis for the structure. So if under this Bayesian network learning, if we are using the parameter learning, then that is considered to be a structure will be known and it will also be fully observable. If suppose we are using the structural learning, now we are going to find out the structure. Therefore, here the settings will be an unknown structure and it will be observable. If suppose we are using an EM algorithm, now the structure will be known, but we cannot find out the variables. Therefore, it is an hidden variable. If but both the unknown structure and hidden variables are there, then what we can do, we can go for the next model, that is the nearest neighbor model. Okay. So here it is considered to have the properties of an input x, which are similar to the neighborhood points of the x. So how to find out what will be the concept here? Here we can use the k nearest neighbor method. Okay. So we will find out the distance from that particular point, what are the nearest neighbors are present, and then we will find out the distance of each and every neighbors, and we will find out the average distance, and we will be calculating the complexity. Okay, see here the various data are present, and we are going to find out who all are the neighbors present to a particular node. So we will be finding out the distance of this. We will be setting up some shortest distance, and then we will be find out who all are the neighbors for that particular node with that shortest distance, and then we will be finding out whether they are similar or not. Okay. And the next one is considered to be the logical theory. So under this logical theories, we will be having using the supervised learning with some logical formulations. So we will be finding out the attributes we are considered to be the unary predicates, and what are the various instances are there that will be considered to be the logical sentences, and the classifications, whether it is a positive or negative, it will be depending upon the representations, whether it is a q of xi or negation of q of xi. And then we will be having the descriptions and the classifications of sentences under this training sentence. Okay, so in order to have the classifications, we will be using both the reasons and the descriptions, that is both the hypothesis and the descriptions. So for example, you see here they have given the input as the name of the father and who all are their mother, how we are representing them, and married with whom, and whether it is who he is a male or female, and who all are the grandparents and not the grandparents. Okay. So in order to have this, if suppose we want to find the grandparent of xy, then what we will do for all the values of z, we will be finding out the mothers of these two people or the various combinations. If there are three persons are there, x, y and z, then we have to find out the relations in between x and y and z and x and z, and then we will be having the various combinations. So that what are the various logical combinations can be done within a particular group of people, that will be done under this logical theory part. See, again they are doing the groupings under this logical theory. Okay, see, first it is like this. If suppose we are introducing any people, then we will be extend our decision boundary. Again, if suppose any people are, then again we have to have the decision boundary by neglecting that, such that the logical theory will be analyzed. Okay, and the next one is considered to be the analytical learning. So here we are doing what? We are finding out the analytical part. Okay, so we are using the size of the hypothesis. So the size of the hypothesis will be learned from by means of having the expert system, that is the background knowledge, and from that we have to conclude the analysis part. So in order to have the analytical learning, we are in need of the prior knowledge of the learning. And the next one is considered to be the explanation based learning. Okay, so under this explanation based learning, we are in need of an observed instance. If suppose we are having any instance that is observed, we have to explain that observed instance, and in order to have the speed up of the learning, how we are going for this observation. Okay, and after finding out this, we have to find out what is the cost of determining such kind of observation, and whether it is benefit for application. If the cost is more, again we have to define the system. And the next one is considered to be the relevance based learning. So this is an explanation based. Now what is the observation given, from there we are learning. This is considered to be the relevance. Relevance means the similarity. Okay, what are the already present existing instances are there, and what is its property, and based on this property how we can group. Okay, and after this we are learning a new rule that explains this kind of relevance based observations. And the next one is considered to be the knowledge based inductive learning. So under this knowledge based inductive learning, we will be using only the hypothesis which is consistent with the prior knowledge and the prior observation. Okay, that is considered to be the knowledge based learning. So in order to have this kind of knowledge based learning, it will be introduced under the part of the smart medical systems. Okay, so the medical student, if suppose any student is there in a particular medical institute, he will observe the session in between the doctor and patient, and he will conclude a particular medication process, such that a new system can be developed. So how this new system can be developed? This new system can be developed only by means of the knowledge incurred from them. Okay, and the next one is considered to be the reinforcement learning. So this reinforcement learning, mainly it is done only by means of the reward. So the main aim of this reinforcement learning is, in order to maximize the rewards, we will be going for this learning. So in order to have the policy, it will be mapping the states for various particular actions. So under this reinforcement learning, it uses the process of Markov decision process, where it will has various set of states and various set of actions. So in order to have the reward function, it will be finding out, combining the states and the actions in order to achieve the rewards. Okay. So in order to have this, the various features, the settings to be enabled under this reinforcement learning are: one is considered to be fully or partially observable environment, or whether the environment is determinable, or it is considered to be a stochastic, or whether it has any model or it doesn't have any model, or whether the rewards is achieved in terms of any goal state or in any other states. Okay, so this all to be identified under this reinforcement learning. So mainly it is concerned with what? It is concerned with, in order to have an optimal policy. Okay, so it is considered to be a under exploitation trade-off, it is considered to be a model-free reinforcement learning. So under model-free reinforcement learning, it learns a controller without learning first the model. It will not have any model, it will learn the controller. Okay, and if suppose it is a model based, it has to learn the model first and then it goes for the other process. And the next one is considered to be the unsupervised learning. So unsupervised learning means it learns the patterns from all the data, that is considered to be an unlabeled data. And the approaches used under this unsupervised learning are: one is considered to be the clustering, and another one is considered to be the density estimation technique. Okay. So the performance task under this are: first one is considered to be, we have to understand the system and we have to visualize the system, and then we can also detect various anomalies entering into a system. If suppose we want to retrieve any information from our developed model, that can also be done. And if suppose we want to compress any data, that data compression techniques is also introduced under this unsupervised learning. Okay. So in order to evaluate the performance of a system, we will do what? We will be randomly splitting the examples into training set and testing set, and then we use the training set in order to learn the reasons, that is the hypothesis, and then we will be measuring the percentage of testing set which is correctly classified by using this hypothesis. And if suppose the percentage is considered to be, the performance is considered to be low now, we will be repeating it with the different kinds of random splits, and then we will be averaging all the results. So see here, this is considered to be the performance evaluation. First, we will be with the training examples, we are finding out the classification error by means of this classification accuracy. So we should have the classification error to be minimized. So when this error will be minimized, if the accuracy is considered to be maximized, the error will be minimized. So we are refining the systems by calculating the error in order to have the better performance. See, this is considered to be rate of change, that is the ROC curve. One is considered to be the false positive and another one is considered to be the false negative. So we are decreasing the value of false negative in order to have the value of better accuracy. So this is considered to be the performance evaluation by considering the accuracy and the coverage. So we should have the better accuracy by under classification. So while we are doing that, we have to consider mainly about the coverage part. Okay. If suppose we are having an analytical graphical part, in order to have the trade-off by means of an empirical learning. So in empirical learning, we will be increasing the number of examples. So whenever we are increasing the samples, we should get a better accuracy. So by means of increasing the examples, we will be generalizing the accuracy part. So in order to have the generalization of the accuracy, first initially we are having the results with 100 examples, then we are using the 200 samples and 400 samples. So mainly the trade-off in empirical learning, it deals with what? The size and complexity of the classifier. Okay, that means the size and complexity means it deals with the amount of training data we are going to use. So if the first we should increase the training data such that the accuracy should be generalized. And the next one is considered to be the computational learning theory. So under this computational learning theory, we will be using the learning part, that is the probably approximate correct theory part. Okay. So the basic principle under this computational learning theory is it will be the optimization, the hypothesis part will be wrong. That means what? It will be certainly be found that with high probability of results after a small number of examples. So in order to have the better result, the same complexity is considered to be what? A function of, it deals with the performance of calculating the confidence value, the error value, and the size of the hypothesis space. Okay. So here also we will be using the same kind of distribution and we will be using the probability and error calculation. So the current machine learning research, what are the various current researches going with this machine learning are? One is considered to be the representations, where under this representations we will be using the sequences of data and we will be finding out whether this is considered to be a spatial data or whether it is considered to be a temporal data. So in order to have this, we will be going for the various probabilistic relational models. So after the representation of data, we will be going for the approaches of learning such as a semi-supervised learning, or we will also use an active learning, a cause-sensitive learning, a collective classification process. Okay. Therefore, by combining all these kinds of theories, that is either it may be a supervised or it may be as unsupervised, we will be using the classification part, the predictant part, the hidden Markov model, or we will be using any types of models in between this classification or the prediction models using supervised and unsupervised. So by using these kinds, the various opportunities of machine learning are, it is used for what? It can be used for an recognition of an image, the voice can be recognized, or each and every optical characters can be recognized, or if suppose we are going for any data analytical part, we can use the intelligent data analysis by means of this machine learning, or we can go for any advanced customization is also be done by means of this machine learning, or if suppose we are using some kind of researches in related with the Internet of Things, the sensory data analysis can also be done by means of this machine learning part. Okay. So with this few words, we are to an end about the machine learning and its introduction of machine learning and its applications. Okay. So in the second session, in the afternoon session, we will be seeing about what are the various algorithms are under machine learning and what is meant by deep learning. And we will see in depth about what is meant by this convolutional neural network under deep learning. Because this convolutional neural network is applied under each and every real applications which represents or which reproduces a better accurate results. Okay. So with this, I will end this session. If you have any queries, you can ask.
Participants, if you have any queries, kindly ask, please. Participants, if you have any queries, kindly ask.
Ma'am, Geeta ma'am,
Uma ma'am. Okay,
Geeta
ma'am.
ma'am,
Ma'am.
shall we end the session?
Yes, ma'am. 2 o'clock start பண்ணிக்கலாம்ல ma'am.
Yes, ma'am. Okay, ma'am.
Okay. Kind information to the participants. The session will be again start at 2 o'clock. Kindly join 15 minutes before the session. And I request the participants to attend the sessions continuously to maintain the AICT norms. So now we will end the session, and I request the participants to join at 1:30. Thank you. Okay, ma'am.
Okay, thank you, ma'am.
Okay.
Ma'am, hello ma'am.
Ma'am, சொல்லுங்க ma'am.
Ma'am, I'm Shanmugapriya ma'am.
Yeah.
Ma'am, this can I have this recordings, ma'am?
What, ma'am?
Recordings, ma'am.
Recordings, ma'am?
I need these recordings, ma'am. Whether it will be mailed to me or.
And we will share the PPT, ma'am, to you.
Okay, ma'am. Please share the recordings, ma'am.
Okay, ma'am.
Okay, ma'am. Thank you, ma'am. A nice class, ma'am. Thank you, ma'am.
Okay, ma'am. Thank you. Again, the session will be started 2 o'clock. Kindly join before 15 minutes of the session. Thank you.
Thank you.